Hey everyone, this is Professor Rossetti with a screencast for the Robo Advisor project. In this project, we'll be creating a Python application to request stock market data from the internet in order to process it and provide the user with a recommendation as to whether or not they should purchase the stock. So, let's get started. I have already set up a repository on github.com. I just created a new repository and downloaded it locally onto my computer and made some commits locally to get it set up. I'll share with you what I've done in a sec, but I've also, so in doing so, I have satisfied the repository requirements, so having certain files in certain places, and also the security requirements. We'll be issuing an HTTP request to an API, and it involves us passing along a secret API key with that request, so we have to take some steps to exclude that secret value from version control. We talked about this in class, but I've already set up the repository, and I have also taken a look at the functionality requirements in terms of information inputs and information outputs, and I've set up a script with some example outputs, namely these right here. So let's take a look at what I've done so far. I have a repository with a README file. It has some instructions on how the user can install and run this program. I have a license, also a gitignore file to specify that the secret values, the secret environment variables that we're storing in a special file called .env, which we talked about during class. Let's ignore that file and its contents from version control. I have a .env file here, and it has my secret API key in it. I also have an empty data directory and an app directory with a Robo Advisor script inside, and it has some example information outputs. Let me take a minute to create a new virtual environment with Anaconda, and we will run the script to see what it looks like, and then we'll move on from there. All right, so the way that I've got this going on is I have in my terminal, I have one tab that I'll be issuing some git commands. In previous screencasts, we've used different version control tools. We have demonstrated how to use the github.com online interface to create versions of our software. And also I've demonstrated how to use the GitHub desktop software to do the same thing. This time I'll be using Git from the command line. No worries if you haven't yet used Git from the command line, but I just wanted to take this opportunity to introduce it to you in case you're interested in it. It also reflects my natural development process, so just sharing with you more information about how you might work with Git in the future. Anyway, so on the left tab in my terminal, I'll be issuing some Git commands, and in the right tab, I'll be executing my script and managing the virtual environment if necessary. So that's what I'll do right now. Let's create a new virtual environment. There's some information about this in the project description. It basically asks us to create a new virtual environment, and then from inside the virtual environment, we'll want to install some packages that we'll need in order to make a web request and to manage environment variables. So, new virtual environment using the conda command line utility. Let's do it. Conda, create a new virtual environment. I'll name mine something like stocks env. Oh, oops, not B, N. Wrong command line argument, my bad. All right. Now I'm going to activate this virtual environment. Let me just check what version of Python is installed. All right, I've been seeing this recently. I'm not really sure what's going on. It looks like it created this virtual environment with Python 2. I'm not really sure what's going on. I'm going to make sure that this virtual environment should have a Python version of 3.7. So let's start this over. I'm going to deactivate this virtual environment. Let's see if we can create another virtual environment and specify that it should use the Python 3.7. So there are some notes about this in the course repository, but just know that we can specify which version of Python just to be sure about creating a virtual environment with the right version of Python. Otherwise, we'll run into some issues when we're trying to install some packages. Let's try this out. Oh, what? Oh, not conda activate. Sorry, I'm going to create a new virtual environment. All right, here we go. Let's try this again. Yikes, I should get these commands right. Oh, we need to specify the name. All right, let's try this again. Finally, I typed the right command. All right, so a new virtual environment is getting created. Hopefully it's the right version of Python this time, 3.7. I might have to pause the video and restart it once this finishes. All right, so it finally finished creating this virtual environment. Now we'll activate it and really hope that Python 3.7 is installed. Okay, great. Let's move on. So we've created a virtual environment. Let's run this script, which is in the app directory. So let's say Python app / roboadvisor.py and see what happens. Okay, we see some example output. That's great. So now we're ready to continue developing our project. It looks like we'll want to accept a user input. We'll do that later. What I'd like to focus on now is actually making this request so that we can get some real data back, and then we'll try to see how we can arrive at these values based on the data response we get back. We know that in order to issue an HTTP request in Python, we can use the requests package. So let's do that right now. I'm going to create a new section in my code just to keep it clean. I'm going to leave all these outputs at the bottom. I'll revise them soon, but in the meantime, I want to focus on these information inputs. Like let's make this request and get this data back. So we know that if we want to use the request package, we have to import it. And then we know from what we've done so far that we can issue a GET request using the request package by invoking the GET method on the request package and then specifying as a parameter the URL to issue the request to. So we will need to figure out what that URL will be, but then when we get this response back, we'll store it in a variable that I'll call response, and then we already took a look at the properties that we'll be able to access on this response object, but for the sake of the screencast, I will share that step as well. So I'm going to ask what data type is this response object, just so we can have that for our awareness, and then we'll see that it will have a status code attribute as well as a text attribute. The status code corresponds to the part of the HTTP response that lets us know how successful this request was, and the text is the actual body of the response we'll get back. So I'm going to just prevent my program from reaching this part down below. I think you could use exit or quit. I just want to be testing this part up top. So What request URL do we need to issue a request to? Let's take a look at the documentation for the AlphaVantage API. From the project description, there's a link to the AlphaVantage API. And we've already, in class, requested an API key from this API, and we've taken a quick look at the documentation. But the type of data that I'd like to get back right now is daily data. And so here's in the documentation are some details about which URL I can make a request to. Looks like we can make a request for CSV data, but we'll be making requests for JSON data. So I'm going to copy this URL here and we'll adapt that URL. Let's take a look at what this URL, when we visit it in a browser, will yield. It yields this data right here. This is looking good in terms of like some kind of data that we can expect to get back and further work with. We see some information about like metadata, like when the request was made and which stock and what kind of information it is. And then also we see a time series of prices by day. So we'll need to further process this data. But anyway, this response data looks good. I don't see any errors. It looks like we can expect to get some data back when we make a request to this URL. I'm confident to move forward. So I'm going to copy this URL into my Python script, and let's take a look. Let's run this script and hopefully see some information about what response we're getting back. Before we run the script, this request package will need to install it. So from within our virtual environment, one time only, we'll say pip install the request package. If you see some errors right now, maybe your virtual environment has Python 2 in it. That will lead to an inability to install the request package successfully. But if we have a virtual environment that's running Python 3, our installation should succeed. So after we install request, we can expect to be able to use it within our script. We've already imported it in the script and invoked it saying request.get some request URL. So we could feel comfortable to run our script now. Let's see what happens. Okay, we see some data coming back. We don't see an error, so this is looking good so far. Whoa, lots of data. Maybe too much for me to wrap my head around at once, but also we see that this data type is a requests.models.response. So if we needed to look at the documentation about this data type online, we could learn more about it. And we see that we have a successful 200 status code. All right, that's great to know. Let me make some notes for myself. Like, hey, this is a response, and this is like 200, and then this is like some string version of a dictionary like object. We know that this response text is a string, so we have to use the JSON module to process it into a dictionary. We've talked about this in class, so I won't go over that point again, but here's where I will import the JSON module. It's a module, it's a Python, it's included in the Python language, so we won't have to install anything. And what we'll want to do here is parse the response text from a string into a dictionary. So I'll call this my parse response variable, and parse, use the JSON module called json.loads to parse the response text into what will be a dictionary. So we'll be able to further work with this parse response. I'm going to drop a breakpoint into my program after making this request so we can see how we might start to get some of these values from it, like latest closing price and the recent high and low values. So when I run my script again, we should have access to the parse response variable. Let's see what data type it is. It should be a dictionary. We have successfully processed it or parsed it from its original representation as a string. Let's just illustrate this real quick. Our response.text before we parsed it with the JSON module was a string. So, but now we've converted it to a dictionary with our parsed response. And whoa, lots of data here. It's kind of confusing looking in its terminal representation of the output, but it's the same thing that we see here in the browser. If we look in the browser, it's easier to understand the structure of this dictionary. It looks like it has two top-level keys or attributes. One is metadata, the other is time series daily. It's really funky and weird that these keys or attributes have spaces in them, but we'll just have to work with that, I guess. So we're making a request. I think that's a step in the right direction, and we're getting a response back. I think now is a good time to create a commit, and then we will continue to work with the response, the parse response. So using my git from the command line, I will go through the process of creating a commit now. If you are using the GitHub desktop software, you can do this commit process in the way you already know, but I'll demonstrate the process of doing this from the command line with you now. So I'm going to say git status to ask what has changed since the last version. I see that some changes have happened to this file, but now I'm curious what changes have been made. You would see all of this in GitHub desktop software visually, but we can also issue some commands to see the same kind of information. So I'll say git diff, like what are the differences in this file? So I've added some lines here and they show up in green. Okay, great. What are we doing here? We're like making a request and it's not resulting in an error, so I guess it's as good of a reason as any to create a new version or commit. So after I've inspected these differences, I'm going to prepare to make a commit by adding these files. I said git add with a dot, that means all the files, but alternatively I could have said git add and the one file at a time. After we do, we see that these files are ready to be committed, so now's the time to make a commit. Git commit with a message of, I guess, issue a request. So this is a very familiar kind of process as you're familiar with, this is a very familiar process as the one you're already used to, of like making a commit with a commit message. So hopefully it's not too foreign. After we make a commit, if we say git status, we see that the changes have been accepted, and if we say git log, we can show a history of our recent commits, and here issue a request is the most recent one. I can say git show to let me know, to see some more details about any one of these commits by specifying the commit's unique identifier, or SHA. So like git show, the unique identifier will also show me the difference between that version and the previous version. All right, anyway, what have we done? We've made a commit, great, but we were in the middle of processing this data return back. So let's get our head back in that. Trying to process this parse response. All right, it's a dictionary, which we saw earlier. I'm going to kind of further inspect this parse response, like parse response, like what are its keys, its top level keys. We see what we saw reflected visually in the browser, that one of the keys is metadata and the other is time series daily. So if you aren't yet familiar with maybe accessing all of the dictionary's keys or values or entries, let's take a look at the documentation about dictionaries in the course repository. There you'll see some examples about what I just did. So accessing, for example, the keys, and this will come in handy again as we continue to work with this nested dictionary. Let's take a look at this metadata attribute of the parse response dictionary. We know because this is a dictionary, we can access its keys like using square brackets. So I will ask what value do we have for this metadata. All right, it looks like that's a dictionary in itself, and it has information about like first of all the symbol, but also when the data was last refreshed. I think I'm going to take this opportunity to print out this information because it's part of the information outputs that we want our program to produce, like the latest data as of this date. So let's see if we can further access this last refreshed date. It looks like these are the keys for this dictionary, but just to repeat this point, let's ask what keys are available on this metadata dictionary. We see there's one called information, one called symbol. It's very weird that these keys have numbers and spaces in them, but we just have to work with it. The last refresh key is the one that I'm interested in, so let's try to access that nested attribute. Yikes, what's going on here? What is this key name? Last refreshed, like that. Let's take it. Okay, so we have a string. I think that's fine enough to print for now. If I want to update its formatting later to be more human friendly, I can. I think that looks decent though. So let's start the process of parsing this response for some information outputs that we know our program needs to produce. So this last refreshed date, for example. So the parse response in the metadata attribute, in the last refreshed attribute, we're working with a nested dictionary structure here, and we'll get this value back. So let's store this in a variable called something like, what did they call it? Last refreshed? Sounds great. And I would like to print that out instead of this hard-coded date here. I'm going to use a format string to do this. Alternatively, you could use string concatenation. We talked about this in class though. I'm going to use string interpolation using a format string. And I'll try to print my last refreshed day there. So I'll comment out my breakpoint, and I'm going to run my script again, and hopefully it's working. And then I'll probably make a commit at that time. But before I do, I'm going to exit from the Python debugger, get back to the command line where I can rerun the script. And now I see the latest, or the last refresh date is this date. Nice job, everyone. I'm going to make a commit now. So repeating this process, get status, like, hey, what files have changed since last time? Get diff, like what has changed in each file? Okay, those are the changes I just made. That reflects my understanding, so I'm ready to make my commit. I will prepare these files to be committed by saying git add all of the files. And finally, I will say git status with a message like get latest refresh date. Sweet. Oops. sorry, git commit. Wow, my commands are struggling today. All right, git commit with a message. Now, if I say git log, I should see that latest version in the history. I do here. Great, let's keep moving on. What else do we need to get from this response? Something about when we made the requests. We can use the datetime module to do that. You've already done that in a different project, so I'll let you do that on your own. But let's see if we can get the latest closing price. That's a good next step. So I think what I'm going to do is continue to investigate using a breakpoint. There's a nested dictionary structure. I'm going to have to work with it a lot. So let's do that. I'm going to rerun my code, my program, and now we have access to the parse response. We saw earlier that its keys, one of them was time series daily, so we'll probably have to focus on this key now. It looks like this. What we can expect is that this time series daily itself will be a dictionary with a number of keys. Each key looks like it represents a day, and that the latest day is on top. So I'm just kind of synthesizing, analyzing with my eyes visually the data structure, and it might give me some clues on how I can process it in Python. What's my goal right now? The goal is to get the latest closing price. Looks like this 107 is the latest closing price from Microsoft. So I'll want to try to write some Python to get this value and print it. What's the latest closing price? Let's prepare to print this using a format string. We'll probably want to also format it as USD. So I will go take a look at a function that I've been using to do that. But let's stay on the topic at hand, which is this will probably be, well, it might be a number, it might be a string. Before I go and try to use this latest close, let's see if we can get its value. Something like that. We have access to the parse response, and we have access to its time series daily key. So let's further inspect this attribute of the parse response dictionary. Okay, lots of stuff to take in, but we already inspected the structure. Looks like it has a key of like 2019-02-20. That's today's date. The date will change over time. We'll have to adjust accordingly, but right now I just want to take one step at a time. So I'm just going to use this key. And I see that this looks like a dictionary, and I want its latest closing price. So the key here is for close. It has a space in it. So let me continue to access the nested attributes. Okay, 107. So this is one way we can get the latest closing price. What data type is this? Did I store it in a variable yet? Let me store it in a variable now. What data type is this? Oh, it looks like a string. So we could probably concatenate it in its current value without error. Let's do that real quick. Let's exit out of the Python debugger and rerun the script again. We should hope to see the latest closing price, like 107. Nice, 107. We'll want to format it as USD. So I'm going to quickly take a function that I've been using in other projects. I'll be back with you in a sec. So I have copied this function that I've been using to convert a number into a price formatted with a $sign and 2 decimals. And so I've called it 2USD, so we can pass in a numeric value and expect to get a nice looking USD value in return. One thing to note is that if we just try to use, if we pass in the latest closing price in its string form, we'll get an error. Let's see this. It's just about the format function here. So the value looks like a float. It's like a string version of a float. So we can convert it to a float before we pass it into the USD function. And so hopefully the USD function that I've created will work now. Let's run this script. Great. We see now that this 107 is formatted as USD. Nice. Nice, nice, nice. Okay. So we got the latest closing price. Have we made a commit yet? No. I think now is a great time to make that commit. Let's do the process. Git status. What has changed? Okay. Git diff. How has it changed? All right. I'm adding a function. Also parsing the nested structure to get the latest closing price and printing it. Okay, so we're getting latest closing price. I'm going to prepare these files to be committed, git add all the files, and git commit with a message of like get latest close. Sweet. So we're ready to keep on moving. Recent high price and recent low. We've been kind of working with this with the prices, so we might choose to move on in getting the recent high prices and recent low prices, but something's bothering me. It's the way that we're accessing the latest closing price. Right now we're saying, hey, give us the closing price for this date, but tomorrow this isn't going to be the latest closing price anymore. So we need to make this a little more dynamic. The latest day here is not always going to be 2019-02. I'm going to abstract this concept away. We need to make it a little more dynamic. Before we do, let me just test that this way of passing in a key to a dictionary will still work. I know it's going to work, but I just want to illustrate this to you. So the latest day, we've just kind of like abstracted this key name out into its own variable, and we can make it more dynamic. Let's run the script real quick. Okay, it's working still. Great, 107. Sweet. The question is, though, how do we dynamically get what this latest day is? Let me drop my breakpoint again and investigate. Rerun the script. Enter the Python debugger, which we have access to the parse response. And it's time series daily. I might further abstract this into its own variable called like TS or something like that, just to be working in a more shorthand way, or like TSD. All right, so now we have this time series daily object. It's our dictionary with all of the daily prices in it. It's a little hard to read, but let's ask for what the keys are of this dictionary. Okay, we see all these dates. So maybe we can just ask for the first one, and if we assume that they're ordered with the latest on top, then that's the latest date. So is it possible, like this looks like an array, but also I see this dict keys. Let's see, what data type is this? Dictionary keys. Okay, it looks like a list. I wonder if we can convert it to a list though. Sometimes you could do this in line, but I think for this, for some reason oh, okay. That's looking like we can do it in line. Great. It looks like we can convert it to a list. What would happen if we did that? Here's where I'm seeing an error. That's weird. What I'm going to do is store the keys in a variable first, and we can get past this error. Python, not cool. Anyway, like date keys, something like that, a new variable. And then can we convert this to a list? Yikes, what's going on here? Let's see if maybe we just have to use variable assignment, like dates. Okay, I guess we just have to variable assign. Python, that's really weird, but we're just gonna work with it. And what's our dates now? Okay, it looks like it's a list. It is. Okay, so now we have a list. We know how to work with lists. So why did I do this, converting it to a list? It's so that we can work with a data type that's familiar. I already know I can call I can access any item of this list by its index. So I could say dates 0 or the first item, and that will get me this this date string 2019-220, the one that we're looking for. Okay. A number of steps that I just did there. What did we do though? I said the date keys are, oh, let's see if we could do this all in one just to get the dates. Before I did something like this, and it worked, I believe. Yeah. All right, let's do this all in line like this. Dates equals a list version of the dictionary's keys. So then the latest day then will just be the first item in the dates list. To be more safe, I might sort this to ensure that the latest day is first, but right now we're assuming that the latest day is first. I'm just going to make some notes about this in the comments. If the data structure changes later, we might have to update our code if we don't make a sorting step now. So what am I saying here? Assumes first day is on top, but consider sorting to ensure the latest day is first. Okay, fine. Dates, a list of days, the latest day. Let's rerun the script and see if it works. We're making incremental progress here. All right, our latest closing price is still 107. This is looking good. So we've, instead of hard coding this latest day, we have dynamically accessed the latest day's worth of data. I think this is a great milestone, so let's make a commit. Git status, git diff, git add all the files, git commit with a message of dynamically get latest day close. All right, cool. So now I'm more comfortable moving on to the next parts of this output, the recent high and the recent low. We need to think about this for a sec. Let's look at the data structure in the browser and see. Let's try to make a strategy. Our goal is to get the latest, or what are we looking for right now? The recent high. What do we mean by recent? Let's go take a look at the project description. The calculation requirements specify what we're talking about here. For latest closing price, for recent high, we want the maximum daily high price over all of the dates that we have available to us in our response data. The maximum of all of the high prices. Okay, so let's just start. The maximum of all the high prices. Let me adjust this output to prepare. I'm abstracting this concept away of the recent high. It's the maximum of all the high prices. So recent high is what I'll call this variable. It's going to be the maximum of all of the high prices. So it's going to be something. I guess I know from working with lists that if I have the highs, if it's some list, then I could take the max of that list. Let me test this out real quick. For example, if our prices were 10 and 20 and 30 and 5, we would expect the recent high to be the maximum of these values, which is 30. Let me run this program real quick and we'll see if my understanding is right. Okay, recent high 30. Okay, so that confirms that we can use the maximum function on a list of high prices. And right now I've just used some placeholder values for what those high prices are. But we actually have to get these prices. And it might not be immediately clear how we could do that. Let's take a look at this data structure and make a plan. So we know that we can access any individual day dictionary's high price with this attribute here. So one thing that I'm thinking is like maybe we could loop through all of these days and assemble a new list just with these high prices. We've done this before, but when we've done it before, we've been working with a list of dictionaries. Here we're just working with a dictionary. So how could we loop through all of the dictionary's keys? There are some notes about this in the course repository, the documentation about dictionaries. Let's take a look. Like, can we loop through all of the keys? I guess let's try some kind of looping approach, not necessarily with the items, but just with the keys. We saw that maybe if we convert keys to a list, and we can maybe like loop through them. I don't know. We'll have to try some things out. Let's drop a breakpoint in our code to try to figure this out. What are we doing here? We're going to get the high price from each day. How do I want to structure this? This is a good example. I'm going to leave it commented out for you. All right, let's try this again though. High prices, empty. Like maybe can we loop through and append a new high price to this list of high prices? Let's take a look. For some item in a list of items, let's see looping through the keys, our dates. We know this is a list already, so we could like loop through each date and print it out. Let's try that real quick. Is this looping structure going to do what we hope? Let's take a look. All right, we're seeing all the dates. That's cool. It looks like we're seeing an error about the max, trying to invoke that on an empty list, but so I guess now let's start to compile that list of dates, or high prices actually. So what could we do with any one of these dates? I guess we can invoke, we can use it as a key to the time series daily data, and then instead of getting the closing price, we can get the high price. Let's do that now. Not the close, but what is the key that we're looking for here? The high. So I'm going to append this value to our empty list. And then when we try to take the maximum of it, this list will be compiled so then we can take the maximum of it. All right, let's try this again. Recent high, $97. Does that look right? No. Like here's a high of 107. Oh, these values are strings. So it's like comparing them as strings. That's not good. We'll need to convert them to floats in order to make sure they're being calculated in the right way. So instead of appending the high price, let's append a float version of it. Now, if we rerun, hopefully we'll see a higher recent high, 116. Great. Okay, cool. We've got the recent high price. So I'm going to make a commit now. Repeat the process. Git status, git diff, like what has changed, git add all the files to be committed, and then git commit with a message of get latest high price. Cool. We're doing pretty well so far. We're moving through all of these challenges. The recent low is next. I think we could take an approach similar to the one that we just took to get the high price, but we can also do like low prices. Instead of the high, we'll use the low key. All right. So now if we try to print this out, it should work. That was not that bad. Well, assuming it does work, let's take a look. Let's try this script out. Yikes, recent low is not defined. Right. Recent low. We'll have a list of all the lows, but we'll want to take the minimum of it. Basically, the project description asks us to take the minimum of all the low prices. So that should give us the recent low. Recent low, 93. All right, this is starting to look really good. Nice job, everyone. Let's make another commit. Git status, git diff, git add, git commit, get recent low price. Cool. So we're making really good progress. There are some aspects of this project that I'll leave you to do, But the final one that I'd like to walk you through, that's maybe the hardest remaining part of this project, is the writing values to CSV as part of our information outputs. So you'll want to make a recommendation, but the logic that you'll want to use for why to recommend whether the user should either buy or not buy, or buy or sell, or various levels of confidence with this recommendation. You want to do that on your own, and you could use these values that we have gotten together as part of that algorithm that you design to get to produce that recommendation. I assume that you'll be able to do that. But finally, we also want to write a report of data into the data directory. We want to write a CSV file into the data directory. And I'd like to walk you through how we might do that now. So, I guess, let me just update my outputs to reflect my intention to do this, like writing CSV file, or writing data to CSV. Maybe I'll do that after we get the request back. Before we crunch that data. Maybe I'll do it afterwards. That's fine. Okay, anyway, so we're going to write data to CSV. Let's actually do that. How do we do that? We could use the CSV module. We could use the pandas package. I think it would be pretty easy to use the pandas package, but I want to try to keep this simple as possible, so I'll just use the CSV module. Let's consult the notes about the CSV module in the course repository. I'm going to find the file about the CSV module, and let's try to leverage this template of how we might write some data to a CSV file. I'm going to move the import statement up to the top. I probably prefer to keep the modules before the package, and sometimes I might separate them like that. I'll probably do that now. But all right, we want to write these values to CSV. I guess we don't really have the values yet. Let's try to write something to CSV, and then we'll see how we can adapt our program to actually write them. I'll probably do this at the end. So CSV file path, we'll want to write it to a file in the data directory, something corresponding with the stock symbol, like MSFT prices or something like that, but I'm just going to call my CSV file prices. We'll have to modify this file path in a sec, but let's just write this dummy data in there, see what happens, and we'll go from there. Okay, what happened? We see a new prices.csv file in the root directory of this repository. It looks like it wrote some CSV in there. Okay, we're ready to do more with this, to further adapt it. We don't want to write the prices CSV file to the root directory. We want to write it to the data directory. So I'm just going to get rid of it. And we'll want to specify the file path so that we're writing the price, we're using a file in the data directory. Let's try this. So the files in the data directory have been ignored, so I might not be able to view them. Oh, here we go. here's this prices.csv. Right now it's just some teams. At this time, I'm probably going to make a commit and say like write some data to a CSV file. Before I do that, I'm going to update this file path so it can be friendlier across browsers, across operating systems, because the Windows operating system slashes go the other way. So we know already from working with the OS module that we can assemble some file paths using the OS module. Let's take a look at our notes about the OS module in the course repository. Find file about the OS module. All right. File operations. We're going to use this file.path.join to join these file paths in a more friendly way. So join together whatever directory this file is in. It will be the app directory. From the app directory, navigate up one directory back into the root directory of our repository, then navigate into the data directory, and then the prices.csv file in the data directory is the one we want. I'm going to delete the current prices.csv file, and let's test this out to make sure it's working. All right. Prices. All right, it's back in. I think what I'd like to do is also include this CSV file path in my output. So like writing data to CSV, like which one though? I'll just include the file path in here, which means I'll have to do this above our print statement. That's fine. I'm just going to run this again and see. Writing data to CSV file. All right, the file path is a little weird. That's okay. So I'm ready to make a commit. Let's do it. Git status, git diff. We're writing some example data to CSV. Add the files, commit, write example data to CSV. So, sweet. Except we don't want to write this example data. We actually want to write real data about our prices. Let's see how we have to get a data structure, how we need to change our data structure, or let's see what values we need to get from our data structure. Looks like we need to figure out what the headers will be. And we'll have to write the headers, and then we'll probably loop through each day and write these rows. So we'll probably have to do some looping here to write each row. We'll have to get the headers. So I'm going to abstract this concept away. CSV headers. Some list of headers. Let's take a look at the project description to see what those headers should be, although they are generally going to correspond with these keys for each day. Project description. Here is an example of the values we expect to have in the CSV file. Timestamp, open, high, low, close, volume. These will be our headers. So at this point, I'm just going to see if I can write one row that will work with these headers. So for each of these headers, let's write a row corresponding to the expected values. Let's see if we could just use example values like to-dos. What I'm doing right now is I'm just assembling a dictionary for assembling a dictionary that will get written to the CSV file. Each dictionary will represent a single row. So let's see what happens when we do this now. Let's rerun the script. Oops, syntax error. Why? Oh, need a colon. Okay, oops. Okay, prices. Okay, we have the headers. That's great. And now we actually have to try to write a bunch of values in here. Like maybe we want to write 2 rows. Okay, this is a good first step. I'm going to make a commit like prepare to write CSV data. And then in the next step, we will actually try to figure out what these rows need to be. So it's commit time. Oh, sorry, I'm using some shorthand. Git status. Git diff. All right. Git add these files. Git commit. Write expected headers to CSV file. Great. But we want the actual data, so let's try to figure out a strategy. We'll probably want to loop through each day and write a row for that day. Let's see if we can adapt the loop that we're doing for the dates. I know a way that I'm going to consolidate all of this code in the future to do it in a more streamlined way, but let me do this separately right now, and then I'll make that other step later. Let's see if I can just iterate through the dates and see if that will get me farther. So here, I'm going to try to write one of these rows for each date. So we know that each one of these dates is a string like this, so that might be a good value to write as my timestamp. Let's take a look. Yeah, we can just write the date there. So this is a great practice. Let's just try to get the timestamp. So each date in the list of dates will be a new day. So let's write this. Let's write each day to a new row. And let's try this out. Cool. So we see now that there are a number of rows, one per each day. This is looking good. And now we just have to fill in the rest of this. I'm thinking that one potential strategy would be for me to do more lookups to get the dictionary corresponding to each date. There's a lot of duplication already starting to happen. I think as an eventual step, what I'd like to do here is instead of constructing these lists separately of like high prices and low prices, these being separate lists, I probably want to loop through the dates and construct a list of dictionaries, which I can then loop through here instead of looping through the dates. That's where I think I need to go, but let me continue to go in the way that I'm working towards right now. So we need something about like the prices, this dictionary of prices. I might just call it like, I guess maybe prices. It's going to equal dictionary, and then we could probably just write like the open price I guess let's see what we need to do here. I'm going to drop a breakpoint into my code within this loop, and we'll have access to this date variable so we can keep working. So what's the date right now? Okay. Let's adapt this approach that we've used above, how we are asking for the dictionary of prices corresponding to this date. So I think this should be easy for us to access the attributes of this dictionary and just write them to a CSV file. So I guess this is our prices dictionary. Like daily prices. And then the open will be us accessing this attribute of that dictionary. So we can here maybe access the open and the high and the low and the close and the volume. I think all of these are attributes on this dictionary. Open, high, low, close, and volume. So let's run this and see if it's gonna work. The fun part. All right. Sweet. We see some values. Let's quickly check to make sure that they're as we expect. The open 107.86 most recently. 107.86. High 107.94. Okay. Low 106.29. Yeah. And close 107.03. Maybe not correct. Close 107.03. Let's take a look at the code. I might have made a mistake here. Timestamp open, high, low, close volume. Timestamp open, high, low, close volume. Open, high, low, close volume. What's going on here? Is this happening right? Oh, let me refresh this. Could be that this data is old. Yeah, okay. So now the latest closing, the latest low, 106, close 107.07. Let's rerun this again real quick. These values are changing. 107.05. Let's look at the last day, 219. That won't be changing. So, all right, it's these values here: 107, 108, 107, 108, 1798. 107, 108, 107, 108, 1798. Okay, great. This is working as desired. So we've written these prices to a CSV file. Nice job. It looks like these values aren't formatted as USD. I think we'll want to do that. Let's see, project, description. Oh, I guess it's okay for us to just write these values like that. That's fine. Let's make a commit because we've written these files. Excuse me, we've written these rows to the CSV file. Git status, what has changed? Git diff, how has it changed? No longer writing some to-dos, but actually looping through each day and writing the daily prices to the CSV file. So git add these files to be committed, git commit with a message of write all daily prices to CSV. Cool. Nice job, everyone. The final thing I'm going to do right now is push these changes up to github.com so we can see them reflected online. Git push origin master. And after we do all these changes, I should be able to view them in my remote repository. So currently, or previously, the remote repository was in its state as it was in when we first created it. But now if I refresh the page, it will reflect all the changes I've been making recently, including in the Robo Advisor script. What are we doing so far? We've done most of the outputs. We've written to CSV file. We've printed all of these expected outputs. I'll leave you to do the recommendation on your own. The last thing I'll do with you right now is let's read our API key from the environment, the .env file. Right now I'm just using a demo URL. Excuse me. The URL, the request URL, it's using a demo API key. I'm surprised that we haven't seen a message yet that says, hey, please specify your own API key. I just want to show you how to do this so you'll have this. This is the final thing that I'll share with you in the screencast. I'm going to take a break though. My brain is getting a little tired. I'll be right back with you. So now let's focus on assembling this URL, this request URL. So far we've been using the same URL, and we saw in class that sometimes using the demo API key doesn't authenticate us, and we get a response that doesn't have data in it. I'm surprised that hasn't happened to us yet in the screencast, but we'll want to actually use some real API key here. And also, we want to allow the user to specify which stock symbol they're interested in. So we'll need to make this string a little more dynamic. Let's abstract away both of these concepts into their own variables and use a format string for a string interpolation. So first, the stock symbol. Let's call it symbol. I'll start it as a hard-coded value, but you want to ask the user for this. Second, the API key. So let's just test to see if this format string is working properly. We still get this data back. That's awesome. Let's keep moving here. How do we get our actual API key though? Well, remember from the setup and also from the project description that we have stored our real API key in this .env file as a environment variable, and this is called, I've called it AlphaVantage API key. So the contents of the .env file look something like this, where it says AlphaVantage API key, that's the name of the environment variable, and then instead of ABC123, I have my real API key. So when we read this environment variable from the environment, we'll have to specify this environment variable name. So let's remember how to do this. We'll have to use the OS module to read the environment. Let's take a look at the notes about the OS module in the course repository about environment variables. So we can say os.environ.get, the name of our environment variable, and store it in a variable, and we should be good to go. So not demo, but os.environ.get, the name of the API key, or the name of the environment variable. So this should now read the environment variable from our .env file, except we have not yet loaded the contents of the .env file. We'll need to use the .env package to do this. Let's take a look at the notes in the course repository about the .env package. We went over this in class, but I'm just kind of including it in the screencast. So first we'll have to install it, python.env. Let's do that now. And then we can use it like this. So within my virtual environment, I'm going to pip install python.env. So we can use this package in our script. We'll have to import it into our script like this. And then we'll also need to take this step of actually loading the environment variables from that .env file before we can expect to access them. Otherwise, they'll just be none or empty. And we talked about this in class. So I think like right up here near the top is a great place to do that. Definitely before the place where we need to access this API key. So now let's retry this and hopefully it should work. Cool, cool, cool. So if you printed out your API key, you would see what your value is here. I just won't do that because I'm screencasting, but my request is still getting made properly, and we have decreased the number of things left to do to finish this project, and I'm feeling really good with where this project is at right now. I'll probably also take a few steps to simplify this code, and I'm really excited to see if I can create some data visualizations of the closing prices over time. If that's exciting for you too, then I look forward to seeing your data visualizations. Otherwise, after a final commit, I'll end the screencast. So final commit here is I guess loading environment variables from .env file and dynamically constructing the request URL. So I'll make a commit with dynamically construct request URL and then I'll push my changes up to GitHub. The reason why I can push to the origin address, you'll see notes about this in the course repository, but when you clone a repository on GitHub, when it's downloaded onto your computer, it will have the association already set up for you such that the remote address is at an address named origin. So that's what's happening when I say git push origin master, just pushing these changes up to the remote repository. Anyway, that was just a little more git from the command line, and importantly, when I refresh my script on my remote repository, I see the changes reflected there, and this is looking good. Hopefully enough to get the scarier parts of this project to kind of give you some context about them, and I hope that this video is helpful for you, and I'll see you in class. Peace out.